This video is for Math 7 to review inequalities. So we will be writing word sentences as inequalities, and we will also be checking solutions as well as solving one-step inequalities and graphing their solutions. So let's go ahead and get started. So our first couple questions are going to be over writing inequalities. So you will be given a sentence, and you'll have to take that sentence and translate it into an actual inequality. So our first example says the quotient of a number t and 3 is at least 16. So when we're doing these problems, there's a couple things we want to look for. One, we're looking for the word or phrase that tells us the inequality sign that we're using. And then the second thing we look for is the operation that's also happening in that inequality. So I'm going to go ahead and start with finding the phrase that is the inequality. So here that's the phrase at least. So I'm going to underline at least, and that is the actual greater than or equal to inequality sign. And then we have this word quotient, which is division. So here we want the quotient of a number t and 3. So we're going to write t divided by 3 is at least, so greater than or equal to 16. And that's our answer for this problem. T over 3 is greater than or equal to 16. You can also write this as t division sign 13, or 3, excuse me, t division sign 3 is greater than or equal to 16, but this is going to usually be the most popular way that you see a division problem written. Let's go ahead on to our second example. We've got 7 fewer than k is greater than or equal to 13. So with this problem, if we start with the word or phrase that tells us the inequality sign, we have it a little bit easier on this time because it's greater than or equal to, and that's actually the name of the inequality sign. We have the greater than or equal to. So these both happen to be the same inequality sign. And then we have fewer than, which is subtraction. But we have to be careful with subtraction because there are a couple phrases that have us switch the order, and fewer than is actually one of those phrases. So 7 fewer than k means we're taking 7 away from k. So we actually have this written as k minus 7 is greater than or equal to 13. Our next couple problems say to tell whether the given value is a solution or not. So we're given an inequality, x over 3 is greater than or equal to negative 4. So this is our inequality. Then this is the possible solution. We actually take that solution, plug it in, and check to see, does that make the inequality true? So right next to this problem, I'm going to rewrite this with the actual given solution plugged in. So negative 12 over 3 is greater than or equal to negative 4. So once we have our possible solution plugged in, so I replaced my x with this negative 12 since that's what we were given, I actually need to do that math. So negative 12 divided by 3 is negative 4, and then we keep everything the same. So now we have to decide, is negative 4 greater than or equal to negative 4? So it's not greater than, but it is equal to. So because that is true, our answer here is yes. X being negative 12 is a possible solution for this inequality. Our second inequality says negative 4 minus 7 or minus y is greater than negative 7. So here's our inequality here. We take this value, x is equal to 5, and we're going to, should be y, y is equal to 5. So we're going to plug in 5 for y. So again, right next to it, I'm going to have negative 4 minus 5 is greater than negative 7. So I've plugged in my value for y here, what I was given, and then I actually need to do that math. Now, when we look at this problem, negative 4 minus 5, that's one of those type of integer problems that are very easily missed. So sometimes it does help us to do that keep, change, change. So we would have negative 4 plus negative 5 is greater than negative 7. Some of you can do negative 4 minus 5 completely fine. Others need to use that keep, change, change. But for here, negative 4 minus 5, that is negative 9 is greater than negative 7. So now we have to decide, is negative 9 greater than negative 7? So the second piece that makes this problem slightly tricky is that we have negative values. And sometimes we get confused at which number is larger. So when you're looking at negative numbers, the number that's closest to 0 is the larger of the two numbers. So here, negative 7 is closer to 0. So that's actually larger than negative 9. So that makes this not true. So our answer is no. y cannot equal 5. That is not a possible solution. So when we're doing these problems, we need to show the plug-in step. So replacing the variable with the value given. We need to show the actual math step. So like here I did the division, here I did the subtraction, and then yes or no. Is this a possible solution or is it not a possible solution? Okay, we're going to go ahead and move on to solving the inequalities and then graphing their solutions. So this is a little bit different than just solving one-step equations, but the process is the same. Our answer just looks slightly different. So here we've got negative 17.5 is greater than or equal to h plus 6. So we're going to approach this problem like we would any other one-step equation. So we're going to first draw our railroad tracks so I can separate my left and my right side of my inequality here. And then I need to look to try and get my variable all by itself. So here I'm trying to get h all alone. So since I'm adding 6 to it, I'm actually going to subtract. I'm going to use the inverse operation. So that allows me to get rid of those 6's. I'm left with just my h. And then I need to take negative 17.5 and subtract 6 from that. Again, that can be kind of a tricky problem. If you write this beside negative 17.5 minus 6, it could help you to do the keep change and have it negative 17.5 plus negative 6. That can help. But your answer here should be negative 23.5. We know that negative 23.5 is greater than or equal to h, or we can look at it almost reading it backwards. H is less than or equal to negative 23.5. So we're going to put this on a number line. This is how we're going to show our answer. So our number line doesn't have to be super detailed. I'm actually going to put our number here, negative 23.5, in the middle. And then when I'm thinking about one number to either side, I'll just go by 1/2. So to the right, it's going to be negative 23. To the left is going to be negative 24. So now what we have to decide on this problem is our circle, when we graph, going to be an open circle or a closed circle. So because we have this or equal to part, this is going to be a closed circle. So on negative 23.5, I'm going to plot a solid colored in circle. And then h is less than or equal to that. So smaller numbers is where we have to shade. So we're going to shade towards the left. And that's going to be our final answer there. So the process of solving for our variable is the exact same as solving one-step equations, just our answer is going to look slightly different. So let's go ahead on to our second one. We've got b minus 7.3 is less than or equal to 4.2. So again, I'm going to draw my railroad tracks. I want to get b all by itself. So I want to add 7.3 both sides. That allows me to cross off my 7.3s on the left side. I'm left with my variable b. I bring down my inequality sign, the less than or equal to. And here, when we're adding with decimals, we need to make sure our decimals are lined up. And here they happen to be anyway. When we add these together, we get 11.5. So b is less than or equal to 11.5. So again, I'm going to put this on a number line. It's going to put 3 dash marks, put 11.5 in the middle. Your number line does not have to look exactly like this. There's numerous ways we can draw number lines. I'm just trying to make mine very simple. So here, again, I'm going to count by 1/2. And since we're doing positives, to the right is going to be 12, to the left is going to be 11. So again, now we need to decide, is our circle open or closed? With this inequality sign, it again is going to be a closed circle. So on 11.5, I'm going to color in my circle, and b needs to be less than that. So I need numbers smaller than 11.5. So I'm going to shade again towards the left. So we're going to keep on going with solving inequalities and graphing their solutions, but we're going to now step into multiplication and division. And we have a golden rule we have to remember, that if we're dividing both sides or multiplying both sides by a negative number, we need to flip our inequality sign. So these may have an extra little step in there. Our first one here is 1.5 is less than 3n. So I'm going to, again, like I start all of these problems, draw my railroad tracks. And I want to get n all by itself. So I need to divide here. Since 3 and n right next to each other means multiplication, we're going to divide. So that allows me to cross off my 3's. I'm left with just n, bring down my inequality sign, and I have to take my 1.5 and divide it into 3 even groups, and that gives us 1/2 or 0.5. So then our last step here is to plot on a number line. We did not need to flip our inequality sign because we divided both sides by a positive number, not by a negative number. So we leave everything else alone. So I'm going to plot my 0.5. Again, I'm just going to count by halves. So I've got 1 to the right and 0 to the left. So for this one, my circle is actually going to be open. There's no or equal to here. So there's going to be an open circle on 0.5, and n needs to be larger than 0.5. So in this case, I'm actually going to shade my arrow in the right direction, towards the right, all towards numbers that are greater than 0.5. And our last question, we've got -4 is less than or equal to -c over 9, or -c ninths. So here, this is a division problem, so we're going to use multiplication to solve it. And we need to get rid of both the negative and the denominator 9 to get c all by itself. So we're actually here multiplying by a -9. So we'll multiply this left side by a -9 as well. Here's where that golden rule comes into play. So because we had to multiply both sides by a -9 to get just our c by itself, we actually flip our inequality sign. So it's less than or equal to, or greater than or equal to now if we're reading from left to right. So we've got -9 times a -4. Negative times a negative is a positive. So 9 times 4 is 36. So here we have 36 is greater than or equal to c. So again, we're going to put this on our number line. We've got whole numbers here, so I'm actually going to just count by whole numbers. I've got 36, 35 to the left, 37 to the right. And again, this inequality is going to give us a closed circle because it has that or equal to part. So I'm going to color in my circle on 36. And then for this one, c needs to be smaller than or equal to 36. So smaller than, we're going to shade towards the left. So a few of these have been kind of strange. Our variable has been on the right side instead of the left side, which is what we're used to. So you have to make sure you're reading them almost backwards. So like for this one here, 36 is greater than or equal to whatever c is. So c can be 36, but it can't be anything bigger than that. So that makes us shade in the left direction towards the smaller numbers. Some students like to take this and rewrite it, but make sure you flip the entire thing, including the inequality. So I could write this as c is less than or equal to 36. Both of these are the exact same thing, but you do need to be careful if you rewrite the inequality with your variable on the left, because sometimes students forget to flip the inequality sign as well. So a really good way to do this is plugging in a value. So here I'm shading towards the left, saying 35 is a possible solution. So a really quick way to check that is if I were to plug in that value, 36 is greater than or equal to 35. Is that true? So if I'm looking at this inequality, 36 is greater than 35, so I know that's correct, meaning my arrow is pointing in the correct direction. So make sure you're very careful, take the extra time, check your work, make sure you've got the correct arrow direction, make sure your circles are either closed or open depending on the inequality sign. So feel free to rewatch any section of this video, look over old homework assignments, old notes, and good luck studying.